Today we are talking about isolations. So what that is are problems where you have a lot of letters in them and you guys are like, blah, so many letters. Well, this is to challenge our understanding of the fundamentals of algebra and equation solving. So if we are asked to isolate R, the first thing I want to do is spot R. Okay, there we go. So I'm going to try to get that whole term. I want to get the negative CR alone. So I am going to try to get this 7a away from me. So I'm going to subtract 7a from both sides. I will get negative CR equals a negative 9a. Now, I just want R to be all alone. So I am now going to look at the negative CR. That's really a negative C times R. So in order to break that multiplication, I will divide by a negative C. So R will equal negative 9a over a negative c. Two negatives make a positive, so this is my solution, 9a over c. That is what R is equivalent to. Let's take a look at this. I want to isolate x. Okay, so first thing I scan, whoa, I see all those x's. Okay, they're attached to a k. All right, I need to get all my x's all together somehow. So I am going to try to get, well, first I can simplify these, and I will get 8kx. That's going to equal k minus kx. Now, I need to get all my x's on one side, so I'm going to add kx to both sides. So I will get 9kx equals k. I'm still trying to isolate x, so here's my x. So now I'm going to divide by 9k. Divide by 9k. So x will equal k over 9k. Now, I can cancel this. So if you imagine that I had 3 over 4 times 3, in other words, 3/12, doesn't 3/12 simplify to 1/4? In other words, couldn't I cancel these 3's and get 1/4? Which means I can cancel these k's and I will get 1/9. So in this case, x is equal to 1/9. As you can see in these isolation problems, sometimes our solution has, is 9a over c, and sometimes our solution is just 1/9. Sometimes it's numeric, sometimes it still has some algebra in it. All right, so I'm isolating a. Whoops. Isolating a. Here's my a. All right, what I want to do is, I'm going to use a different color here. I want to get the R away from the A, and I also want to get the W away from it. So I'm going to multiply by the reciprocal. Notice I can't forget about this negative, so that's why I have this negative here. Now see, the R's cancel, the negative W's cancel, so I would just have A on the left, and then I'd have W squared times R over E times a negative W. Now one of my w's can cancel, so I'll get WR over a negative E. You could also write that as negative WR over E. There's a lot of different options. Now, we haven't talked a whole lot about this canceling process here that I just did to get WR over negative E, but that is hopefully similar to, you see some similarities up here in my example that I did right here. Okay, so I need to isolate G. So here's my G. All right, my G is stuck inside parentheses though, so I gotta get rid of those parentheses. I have two options at this point. I could distribute my 4 and get 8a plus 4g. A lot of you guys might like that. I could also just divide everything by 4. So this will cancel, and I divide this by 4. So I'll get 2a plus g equals 3a. I will now subtract 2a. G is going to equal a. Cool. Now, if I had approached it this way, I would subtract 8a. 4g is going to be 4a. I'll divide by 4. G equals a. So both ways work. Cool. I isolated G. It is equivalent to a. This might be one of the trickier kinds. You notice I'm trying to isolate C, and I see it here and here. So I need to use a special trick. It's not a special trick, it's really just the only way to take C away from both the MC and the RC. I'm going to take it as if it is a greatest common multiple, or factor, sorry, and I'm going to reverse distribute it. So notice I took the C away from this term, and it would just create an M. I took the C out of here, and I just got an R. If I then redistributed this, I would get Cm, or MC, minus RC. So this is called reverse distribution. Now I'm going to divide by, M minus R, because I'm trying to isolate C. 0 divided by anything is going to be 0. So C will have to be equal to 0. Alright, I need to isolate B. So here's a B and here's a B. Yeeks. Okay. First thing I want to do is get the B's on both sides, so I'm going to add FB to both sides. AB plus FB equals R squared. Okay, I have a B in both of these. What did we just do? We pulled the common factor away. That is called reverse distribution. In the same way, if you had 8a plus 9a, you could do reverse distribution and go a parentheses 8 plus 9. Here we did b parentheses a plus f. Now I'm going to divide by a plus f. I'm trying to isolate b. So this cancels, so b is r squared over a plus f. And there's my answer. Those are challenging problems. I hope walking through those was helpful. They really get to the heart of whether you understand what you're doing with your algebraic rules of solving equations.